So now that we know about the absolute value function, let's talk about equations that contain an absolute value. And we're going to call an equation that contains an absolute value and nothing more complicated. So an equation that contains an absolute value and is otherwise linear. We're going to call that an absolute value equation. We're going to talk about absolute value equations in one variable that contain only one absolute value. And this will simplify our discussion somewhat. Now, the simplest example of an equation in one variable containing one absolute value, I think, would be an equation something like this. The equation absolute value of x equals 5. Now, how would you go about solving this equation? Well, this tells us that x is a number whose absolute value is 5. We know that the absolute value of 5 is 5. The absolute value of negative 5 is 5. And that's it. 5 and negative 5 are the only two numbers that have absolute value 5. One of the places we can see that is by considering the graph of the absolute value function. We see that any horizontal line crosses this graph twice. For any y value, there are at most two x values that give that y value. So in this case, the absolute value of 5 is 5, the absolute value of negative 5 is 5, and that's it. Our solutions then are x equals 5 or x equals negative 5. We shouldn't say x equals 5 and x equals negative 5 because that would mean both of those are true at the same time. And x can't be at the same time both 5 and negative 5. That doesn't make any sense. So this is the simplest sort of absolute value equation. And this is essentially the way that we will solve all absolute value equations. We'll see that absolute value equations typically have two solutions. What do I mean by typically? I mean unless something strange happens, and we'll talk about what strange things can happen in a future video. There is a step in solving an absolute value equation, and it looks like this step. We went from absolute value of x is 5 to x is 5 or x is negative 5. In general, the step where we remove the absolute value will look like absolute value of some expression equals a number. And this tells us that either our expression equals that number, right, because provided this is a positive number, it's its own absolute value, or that expression equals the opposite of that number, since a number and its opposite have the same absolute value. So let me show you a typical example of an absolute value equation. Let's suppose we have the absolute value equation 4x plus 3 equals 7. We are prepared for the step where we get rid of the absolute value. If the absolute value of 4x plus 3 equals 7, that means that 4x plus 3 is one of the numbers whose absolute value is 7. And of course, again, we think the absolute value of 7 is 7. The absolute value of negative 7 is also 7. In order to have my absolute value be 7, I either need to be 7 or negative 7. Now what do I do to get a solution? Well, I take each of these equations and I solve it. Here I can subtract 3 4x equals 4. Divide both sides by 4, and I get x equals 1. Here I subtract 3. I get 4x equals what? Negative 10. Divide both sides by 4, and I get x equals negative 5/2, just reducing this fraction. Now, a couple of things to notice. First of all, our two values of x are not opposite one another, and we typically don't expect that. Second, we very frequently have fractions turning up when we solve absolute value equations. We can have one solution be a fraction and the other one a whole number. That's no problem. We could have one negative and one positive solution. We could have both negative. We could have both positive. All no problem. Right? The place where we take either the positive or the negative version of a number is in this step where we remove the absolute value. So, I'm going to have you try solving an equation like this. Solve the absolute value equation. Absolute value of 1/2 minus 4 equals 2. Pause the video and try this now. Alright, the first step in solving this equation. Again, I think there are two numbers whose absolute value is 2. If a 1/2x minus 4 has absolute value 2, it is either the case that a 1/2x minus 4 is 2, or that a 1/2x minus 4 is negative 2. Again, this expression has to represent one of the two numbers whose absolute value is 2. And now these are just two linear equations. We add 4 to both sides. We need to get rid of a half. We can either think of this step as dividing by a half or as multiplying by 2. I'm going to write it as dividing by a half. So x is 6 divided by a half is 12. Alright, over here, again I'll add 4 to both sides. I get a 1/2x equals positive 2. Again, dividing both sides by a half. I get x equals 4.